Hello my dear students, welcome to this today's topic, that is HNMR questions came in IIT JAM for last few years. Now to begin with, we are starting from 2022. But question number 12 is like this: an organic compound having molecular formula C9H10O2 exhibits the following spectral characteristics. They have given HNMR of the compound. At the same time, it was given that IR stretching frequency of 1722 centimeter inverse. They have given the four structures A, B, C, D. Out of them, we have to identify the structure which is best fit into the given spectral data. Now let us consider the peak in HNMR, which is appearing at delta 9.72 ppm. Now this clearly indicates the presence of aldehyde in the compound. So based on that, the option A is out because it does not have any aldehyde. Now among the B, C, D, we have to see what all we can cancel. Now let us consider the multiplicity of the same peak, means at delta 9.72 it is given that the signal is appearing as a triplet, means that neighbor hydrogens are 2, then only in HNMR it will come as a triplet, means in the compound there is one CHO and adjacent to that CHO there is one CH2. So based on that, we can cancel the option B also. Now coming to the C and D, in both the cases there is CH2 CHO. Now what is the difference between C and D? C is a para-disubstituted compound and D is a meta-disubstituted compound. Now in order to cancel one, we have to concentrate on the aromatic signals, means in this given data the aromatic signals are at 7.1, which is appearing as a doublet for 2 hydrogen, and another one is the 6.7 doublet, that is also 2 hydrogen. It clearly indicates the presence of the para-disubstituted compound, not the meta-disubstituted compound, because in the meta-disubstituted compound the aromatic hydrogen which is present in between the two functional group, one is methoxy, another one is the CH2CHO, that will appear as a singlet. So based on above analysis, we can consider the C as a final answer, not D. Now let us move to the next question, which appeared in the same year, means the 2022, that is question number 43. In that question, it was asked the number of signals observed in HNMR of the compound. The name of the compound is 2,4,6, 2', 4', 6' hexamethyl biphenyl. Now as we know, in HNMR, number of signals is equal to number of hydrogens in different environments. So if we investigate the structure, then it is clear that there are 3 environments are there. Number 1 is the aromatic hydrogens will be having one environment. Next is the 2 methyl groups, means total 4 methyl groups which are present at the 2, 6, 2', 6', they have the same environment, and another one is the 4', which methyl groups which are present at the para position, they will be having the another environment. So in this molecule there are 3 environments are there. One is for the aromatic hydrogen, one is for the para-methyl groups, one is for the orthomethyl groups. So therefore HNMR of this compound will show the 3 signals. Now let us move to the question which appeared in 2021, that is question number 7. A compound shows 1 HNMR peaks at delta 7.31 for 2 hydrogen, 7.21 for 2 hydrogen, delta 4.5 for 2 hydrogen and 2.3 for 3 hydrogen. The structure of the compound is, there are 4 options A, B, C, D. Out of them, one compound we have to find out which will show the above mentioned HNMR signals. Now in order to solve this, let us first concentrate on the aromatic hydrogens related signals. Now there are two signals are there which are for the aromatic hydrogens, that is at delta 7.31 ppm for 2 hydrogen and at delta 7.21 ppm for 2 hydrogen. So this clearly indicates that the aromatic compound has the 4 hydrogens, means it is a disubstituted compound, it cannot be the monosubstituted compound. So based on this, first we can cancel A because A is a monosubstituted compound. Now for the same 2 peaks, let us consider the number of hydrogens. There are only 2 aromatic signals and each signal is for 2 hydrogens. Now based on this we can cancel the C option also. Why? Because C is one ortho disubstituted compound and the 4 aromatic hydrogens of compound C will have the different signals. So therefore A and C both are not possible. Now coming to the 2 possibilities, either the answer will be B or the answer will be D. So in order to cancel one and to go for the final answer, let us concentrate on the aliphatic region of the given data. So the aliphatic part of this compound are giving 2 signals. One is at delta 4.5 for 2 hydrogen, another one is at delta 2.3 for 3 hydrogen. So let us consider the signal at 4.5, that is for 2 hydrogen, means in the final answer there must be one CH2 group which is having the signal at 4.5, which is quite high. Means by investigating the structure B and D, it is clear that possibility is for the B, not the possibility goes to the D. In D, CH2 group is only attached with the sp2 hybridized carbon of the aromatic ring. So therefore it is expected that CH2 group of D will give the signal in between 2 to 3. But in the given question, that CH2 group is giving signal at 4.5. So option D is also not possible. Hence our final answer is B, and that also can be confirmed by CH3 signal also. In the given data, CH3 group is giving signal at 2.3, but it is only possible in case of the B, because in B methyl group is attached with the sp2 hybridized carbon of the aromatic ring, whereas in case of the D, methyl group is attached with the sp3 hybridized CH2, so it will not give peak at delta 2.3. So with respect to CH2 or with respect to CH3, that answer is B, not D. Let us proceed forward. Question number 38 of 2020, which came in IIT JAM. Let us see the compounds which will have only 2 signals in one HNMR spectrum in 3:2 ratio are. So this question came under MSQ. So we should be careful that out of the 4 given options A, B, C, D, we may have answers more than one. Now if we see the A, B, C, D, out of them, the A and the B are not possible because A gives the 3 signals in HNMR, because one is the COCH3, that CH3 signal, then ortho 2 hydrogens and the meta with respect to COCH3. These are the 3 signals. If we record the 1 HNMR of A, then we are going to get these 3 signals. I repeat, one is the COCH3, next one is the ortho aromatic hydrogens, next is meta aromatic hydrogens. Now coming to compound number B, there actually we will be having the 4 signals because this molecule is highly unsymmetrical. One signal is COCH3, next is that hydrogen which is in between 2 COCH3, that is another signal, and remaining 2 are also aromatic signals. So total this molecule, I mean the B will show the 4 signals. As in the given question, the question is based on the 2 signals, so A and B are no way the answer. Now let us consider the compound number C and the compound number D. Now in both the cases, compound C and the D, we will be having the two signals because they are symmetrical molecule. For C, we will be having two signals. One is the COCH3 signal and another one is the 4 aromatic hydrogens are same. So we will be having two signals. Now coming to the 3:2 ratio of these two signals. Now compulsory it is matching with the 3:2 ratio because COCH3, there are two COCH3 groups are there, so total 6 hydrogens are there and the 4 aromatic hydrogens are there. So if we take the ratio, it will come 3:2. Now coming to the compound number D, there also that is one aliphatic compound and there are also two signals will be there. One is a COCH3 signal, another one is a COCH2 signal. Now 3:2 ratio will come or not, for that COCH3 2 are there, COCH2 also 2 are there, so it is also 6:4, otherwise 3:2. So this question number 38 will be having the two answers C and D. In 2019, let us consider question number 25. In one HNMR of the given molecule, the correct order of chemical shifts of HX, HY, HZ is. Now in the given compound, if we see the environment of the hydrogens or HX, HY and HZ, then it is clear that HZ is attached with the carbon, whereas HX and HY, both of them are attached to oxygen. So based on this, we can tell whatever may be the order, HZ will be having the lowest delta value as it is attached with the carbon, not with oxygen. So based on this, we can cancel again the A and B. Why? In the given options A and B, it is appearing that HZ will be having the highest chemical shift value. So A and B are not the answer. Now let us go to the C and the D. So in order to find out whether HX will be having the highest delta value or HY will be having the highest delta value, we have to see the environment of X and Y. So actually X is OCH3 and the Y is CH2. So as we know that if the environment is same, means OCH3 versus OCH2, lower the number of attached hydrogen, higher will be the delta value. So based on that, OCH2 will be having the higher value than OCH3, means the overall order will be the delta value of HY is greater than HX is greater than HZ. So this option is given in the D option, so therefore answer is D. Now let us go to the 2018 question number 43. Among following hydrocarbons, how many of them would give rise to 3 groups of HNMR peaks with 2:2:3 integration ratio? So this question came under numerical aptitude test. So after investigating all the 4 structures, only we have to write the number, how many. So let us begin with the first one, that is N-hexane. That N-hexane has the molecular formula C6H14. This molecule is highly symmetrical and this molecule will be having the 3 signals because one is the CH3, another one is next to CH3, CH2 signal, and the another one is the CH2 signal. So total 3 environments are there in N-hexane. It is clearly mentioned by the red color, orange color and the green color in the Now let us coming to the another part, means there are 2 parts in this problem. One is there should be the 3 signals and another one is these 3 signals will be having in the integration ratio 2:2:3, that also we have to check. So if we consider the 6 hydrogen means for the 2 CH3 groups and the 2 hydrogens for the CH2 groups means 4 hydrogen, another CH2 group is also 4 hydrogen, the total ratio is 3:2:2. So therefore N-hexane is one answer, counting key it will come. Now we will go to the next compound. That next compound is N-pentane. Its molecular formula is C5H12, and if we see this molecule also will give the three signals. One is the CH3 signal and CH2 signal and the central CH2 signal, which are labeled as the red color, orange color and the green color. Now in this case it is showing the three signals. Now we have to check whether the integration ratio of these three signals will be 2:2:3 or not. Now this, if we see the hydrogens that is in each and every category of the three signals, CH3 category ki 6 hydrogens, now the CH2 categories are there, so 4 hydrogens, and the another CH2 only one is there, so 2 hydrogens, so therefore the ratio is 3:2:1. So this is not matching with the given problem. So therefore, although this N-pentane is showing the three signals, but it will not be the final answer. Now coming to the last molecule, that is Paradite Benzene. Now here also we will be having the three signals, because ethyl group itself will be having the two signals and the 4 aromatic hydrogens will give another signal. So this is also having three signals. Now we have to see whether these three signals ki integration ratio will be 2:2:3 or not. Yes, if we check it, methyl group ki 6 hydrogens, ethyl group ki 4 hydrogens and the 4 aromatic hydrogens. So if we it will show the ratio 3:2:2. So out of these three compounds, N-hexane, N-pentane and Paradithyl benzene, N-hexane and Paradithyl benzene are satisfying the two criteria given in the question number 43, means the compound will show the three signals and their integration ratio will be 2:2:3. So therefore answer will be, how many of them would give rise to these signals and integration ratio? 2. Answer will be 2. Now coming to 2017, in this year question number 19 was based on HNMR question. The number of HNMR signals for the compounds P and Q respectively is, there are two compounds they have given, one is P, another one is Q, and what they are asking us to find out the number of signals present in P and the number of signals present in Q. So let us try to solve this one after another. First, to begin with, let us pick up the P. Now P is a para-disubstituted compound. So if you see that compound, P will give the three signals. One signal is CH3, another signal is ortho to CH3, and that another one is the ortho to nitro group. So these compound will show three signals in its HNMR. So based on this we can cancel C and D, because in the C and D it is P will not give three signals. Now coming to A and B, so there now we have to, in order to pick up finally whether the final answer is A or final answer is B, we have to find out the number of signals for the structure given as Q. Now in this case this Q compound will give the 4 signals, because we know in HNMR number of signals is equal to number of different environment of the hydrogens. So this compound has 4 environments for the hydrogens. Ethyl group ki 2 signals will come, and that isopropyl group ki 2 signals will come. So 2 plus 2 is equal to 4 signals. Isopropyl group is attached with the C double bond O of ester. Ethyl group is attached with the oxygen of ester. Ethyl group 2 signals will give. Isopropyl also will give 2 signals. So 2 plus 2 is equal to 4. So therefore the answer is A, because in the A, P will give 3 signals and the Q will give the 4 signals. Now let us discuss one more numerical, question number 47, which appeared in the same year 2017. At an operational frequency of 350 MHz, the shift in Hertz of resonance from TMS of a proton with chemical shift of 2 ppm is. Now this question is a memory based question. The one very important formula is there in HNMR, that is delta ppm is equal to shift of resonance from TMS in hertz divided by operational frequency or instrumental frequency in megahertz. So therefore, that in this problem delta value is given, which is 2, and the operational frequency or instrumental frequency is given, that is 350 megahertz. In the question they are asking to calculate the shift of resonance from TMS in hertz. So if we multiply the delta value and the operational frequency, means 2 into 350 means 700 hertz is the answer. Now coming to the year of 2015, question number 20, this conceptually this problem is very similar to the 2016 problem. Here also they have given the 4 compounds and we have to arrange them with the correct order with respect to their delta values. Now let us concentrate on the 4 compounds given. They are asking the hydrogen of cyclohexene, hydrogen of benzene, hydrogen of phenylacetylene, the hydrogen which is attached with the acetylenic carbon, and the 4th one is the methyl cyclohexane, the hydrogen of methyl group. These 4 things we have to arrange with the highest delta value to the lowest delta value. So it is needless to tell that aromatic hydrogen will be having the highest value, means the second option will be having the highest delta value. So based on this, A and C are not the answer, final answer will be either B or D. So in order to pick up the final answer, we have to proceed. So if we investigate the given options under B and the D, then we can see that is the aliphatic methyl signal which is attached with the sp3 hybridized carbon, means that is the 4th option that will be having the lowest delta value, because under compound 1 what is there is the hydrogen attached with the sp2 hybridized carbon. Under the compound number 3 hydrogen is attached with the sp hybridized carbon. So these will be having the higher delta value than the compound 4 where the methyl is attached with the sp2. Methyl is attached with the sp3 hybridized carbon. So the highest delta value goes to the aromatic hydrogen of benzene and the lowest delta value comes to the methyl hydrogen of methyl cyclohexane. So therefore this option is available in the B, so B is the final answer. Now coming to year 2014, question number 43A, how many 1H NMR signals are expected for 2-chlorobute-2-ene? So if we write the structure of 2-chlorobute-2-ene, then we can be able to identify there are 3 different environments are there for this compound. One is the CH3 attached with the sp2 hybridized carbon C2, which is in its turn attached with the chlorine. Another CH3 is the C4 that is attached with the sp2 hybridized carbon CH, and the CH itself is olefinic hydrogen. So one CH3 which is at the C1, another CH3 which is that is the C4, and the olefinic hydrogen CH that is the 3rd. So these are the 3 environments. So therefore 1H NMR of this compound 2-chlorobute-2-ene will give the 3 signals. Now coming to the question number 19 of 2013, this question is the number of peaks or signals in 1H NMR of N-dimethyl formamide at 25 degrees centigrade is. So this question is based on one topic, that is carbon nitrogen restricted rotation. So when N-dimethyl formamide if we draw, then apparently it comes in our mind the 2 methyl groups are having the same environment. So these 2 methyl groups will give one signal and the CHO, that hydrogen will give one signal. So total at 25 degrees centigrade means at room temperature, NN dimethyl formamide is supposed to give the two signals, but this is wrong. Unless and until we apply the concept of the CN restricted rotation, the correct answer of this compound will not come. So instead of considering the structure where the carbon and the nitrogen have the single bond, we should not consider that. We have to consider the partial double bond character between the carbon and the nitrogen, means you have to consider the resonance. So if we consider the resonating structure of NN dimethyl formamide, which I have written in the right hand side, it is very clear that at room temperature 25 degrees centigrade, NN dimethyl formamide will give rise to 3 signals in its one HNMR, not 2. So here that hydrogen will give one signal, and coming to the 2CH3, these 2 CH3s have the different environment because one CH3 is adjacent to the O minus and another CH3 is adjacent to the hydrogen. Therefore, these two methyl groups are no way same to same. So therefore, these two CH3 signals will come along with the CH signal. So total at room temperature means 25 degrees centigrade, NN dimethyl formamide will give rise to 3 signals. That is because of the carbon nitrogen restricted rotation.